Okay, so we're going to be talking about rational expressions. Now, the whole point to a rational expression is there is no equal sign. But the other component to a rational expression is the fact that it is a ratio. So anytime I have something like this, I have something on the top, something on the bottom. If I have this, it is a ratio. Now, we of course are doing variable rational expressions, so that means I need to have a variable somewhere in this problem. Now, this wouldn't be a great example because this is a variable and this is a constant. Now, what we really need is something with a variable top and bottom, or at least a variable in the bottom. So in this case, this is a rational expression. And again, it's an expression because there is no equal sign to it. So this is our basic rational expression, 1 over x. But we can get something that's significantly more complex, like x plus 2 over x minus 1. That is also a rational expression right there. Now, you'll notice that these rational expressions are fractional. They are fractions. The good news is we can use rules of fractions to do all of the rules for rational expressions. So if I can add fractions or subtract fractions, if I can multiply fractions, or I can divide fractions, those are going to be the same rules that I can use to add or subtract rational expressions. I can use the same rules to multiply rational expressions or divide rational expressions. So you need to be able to do all of the basic 4 functions for rational expressions. Now, to add or subtract rational expressions, like fractions themselves, we must have common denominators. So in this case, to get common denominators, I'm going to need a 5 here and a 5 here and a 2 here and a 2 here. So I have 5 tenths plus 6 tenths equals 11 tenths. Now I'm not going to simplify that. I'm going to leave it 11 tenths because when I go over here and I find the common denominator, x minus 1, and I come over here and I multiply by x and x, there we go. I am going to put all of this together because I have x minus 1 over x squared minus x plus x squared plus 2x all over x squared minus x. And now I combine like terms, leaving the denominator the same. You'll notice the denominator stays the same. Just like over here, we had tenths and tenths as tenths. X squared minus x, x squared minus x, x squared minus x. Now put these together. I am going to get an x squared plus 3x minus 1. And that is the sum of these two rational expressions. At this point, I'm not technically done yet, because I would need to see, can these be factored and simplified? In this case, I get x minus 1 and x again. I can break them back out. But unfortunately, since I can't break the top up, we are done. Now, when I multiply fractions, I'm simply going straight across the top, straight across the bottom. So that's going to be 3 over 10. You'll notice the denominator does change when we have multiplication of fractions. And we would try to reduce it at this point. Likewise, I'm going to go over here. I'm going to say straight across top, straight across the bottom. X plus 2, because 1 times anything is itself. And down here, I'm going to leave it just like this. You'll notice I could have written it as x squared minus x, or I could have left it like I did, x times x minus 1. Makes no difference because, just like over here, we said we need to simplify. Likewise, we would want to try to simplify if we could. But clearly, I cannot simplify because I can't get rid of an x here and an x here because this is attached by a plus or minus sign. Make sure that if you're reducing, you can only reduce things that are connected by multiplication or division. So again, likewise, we are done here. Okay, now for division of fractions. We have a division of fractions that may have looked like this. Fraction over fraction. But that is literally the same thing as 1/2 divided by 3/5, written like this. What we need to remember is that we never ever can divide by fractions. It doesn't exist, so we have to multiply by the reciprocal. And when I multiply reciprocal, now I simply go across the top, across the bottom, and I have 5/6. Again, I would try to reduce if at all possible. I cannot. So in this case, likewise, 1 over x times, flip it over, x minus 1, x plus 2. So let's multiply across. I get x minus 1 over x times x plus 2. And we would try to reduce if possible. In this case, we cannot reduce. It is not possible. So rational expressions are based on ratios. They have to have variables, and the variable needs to be in the denominator. Otherwise, it's just a linear with times a constant. We need to be able to add, multiply, subtract, and divide. And the rules for rational expressions work exactly the same as fractions because they are literally the same thing. Just one has numbers, the other has variables. Okay, those are the basics.